Hello. Guten Tag. Bonjour. Hola. And thank you everyone for coming. May I have your attention, please? Thank you for coming. We'll talk about HTTP. Symfony is an HTTP framework. We deal with request and response. Voilà. The request is issued by the server. The response is read and interpreted by the browser. Is there a lot of echo? Yeah. Is it possible to? Yes. Okay, cool. So the response is handled by the browser, and we'll see different features that can be enabled in browser at browser level, and improve security. So this is not a Symfony dedicated talk, but mostly HTTP talk that applies to Symfony as well as many other frameworks. So if you're doing Laravel, you could use information in this talk in your Laravel. Is it better? Ah, yes, it's better. Okay, first of all, let's present myself. I'm Romain Neutron. I'm a co-contributor on Symfony for quite a while now, and I'm contributing to many open source libraries, so we may have met each other on the internet. I'm also a mountain lover. This is me in the background. And I love sausage, so I'm very happy to be in Berlin. I'm working at Blackfire, and this is not an ad. I will explain you. So I'm working at Blackfire, and you may know that it's a profiling tool. So Blackfire collects information about what's happening in your application, and renders graph like this one. It's an event dispatcher function call, and it's calling other functions, and we display graph. The first job I had on Blackfire was to create a Chrome extension to simplify the user experience. We wanted a simple button, profile. You are on your web application, and you click profile, and you get the result. So we created a Chrome extension. You'll see at the top right of the screen. You open the extension, you click profile. It embeds the toolbar at the top of the website and says the progression, displays the progression of the profiling. In case of error, so the error is displayed at the top. So it's the progression bar. So when I developed it, I handled the error case because Blackfire used cryptography to be sure that you're allowed to profile the web application displayed in the browser. So I wanted to test my error handling. And so I went on GitHub, because I spent my day on GitHub, and I tried to profile GitHub. And it was supposed to display the bar and turn it red and display an error message. But nothing happened. To explain you, I was injecting an iframe and rendering HTML and animating it with JavaScript. It was not working. And in my console, there was an error, a cryptic error message about content security policy violation. And I didn't know what was that. So I Googled, and I saw that it was a security measure enabled by GitHub on my browser, and that I had to deal with it. So it was the end of my world. Everything was falling down because I was very happy to have developed this Chrome extension from scratch in a week, and nothing happened. This guy predicted that Mir space station was falling in Paris in 2000, and it never happened. It was the end of his world, so it's an icon I will use to represent the end of the world. It's not code of conduct compliant, but I think it's funny. let's go back to my error message. So I discovered this new content security policy header that broke, in some point of view, my Chrome extension. So I had a look at, I hope it's not too small, at GitHub headers. So, and I saw many headers I didn't know. XXSS protection, X content type options, X frame option, strict transport security, and so on. Google had the same. Dropbox, Facebook, Twitter, everybody was using this kind of headers, and I did. And it was the beginning of a new world, because it was the end of my world. So in this talk, we'll cover five headers, X frame option, X content type option, XXSS protection. Very quickly, we'll spend more time on strict transport security, and we'll cover the content security policy case that annoyed me. XSS protection. So XXSS protection is a header introduced by Internet Explorer in a long time ago. It's a tool to prevent reflected XSS. There's two kinds of XSS vulnerabilities. Storage XSS, which is the most known. It's when you store data in the database, and this data contains HTML that is rendered in a template without escaping. You store a script tag, and it's evaluated if it's not escaped. That's why we use Twig, we use Smarty or other templating engine that escape the data from the database and prevent such XSS. But as you may know, Twig provides a raw filter. The raw filter allows you to display data without escaping, and it's useful in some case. But beware of using this. So reflected attack is the same as storage attack, but instead of coming from the database, it comes from the URL. Imagine a URL with query parameters, and you have a query parameters image source, and this image source is provide a URI, and this URI is used as a background image of your website. And if you, instead of using an image source, you use an image source and the quote and the image tag and open a script tag, you could embed a script and execute remote code on the end user browser. And that's a vulnerability. So XXSS protection is just a heuristic that compares query parameters and what's rendered in the DOM. To avoid the XSS vector, you just put the value of the header to 1 enabled, 0 disabled. If you use the option mode equal block, you block the complete rendering of the web page. So, cool header. X content type option. As a Symfony developers, you use the response object. Return new response, body, status code, array of headers. You may use the content type header to specify the content type of your response, but if you don't specify it, it's text HTML in Symfony. Excuse me. And so it's text HTML, but you can, in a new JSON response, it's application JSON. You may be trustful to browsers, but you should not. Because most browsers, including Chrome, Firefox, Safari, when they receive a response, they don't care about the content type value of the header. They're sniffing the first byte of the response. They see an HTML tag, it's text HTML. They see some JSON-like data, it's JSON. And if you want to display the raw HTML in text plain, you would not be able to do that without this header, X content type option. It disables this sniffing of the content type because it can lead to security issue. Imagine you have JavaScript. You send JavaScript, you want a user can upload a file, and you just want to see the raw file in a web view without interpreting it as text plain. And if it's JavaScript, it's interpreted and executed. So it's a vulnerability. You can disable it with no sniff, because I don't see any use case when I want the browser sniffing be useful. OK, now Xframe option. Xframe option has been introduced a long time ago, and it provides you the ability to control on which other website your website can be framed. And this prevents clickjacking. Have you ever seen on Facebook some of your friends posting things quite weird? And it's because they've been in the trap of some kind of clickjacking. Nowadays, it does not appear anymore because Facebook has prevented that. And imagine you have a hacker.com website. And on this hacker.com website, it's just an iframe. You have, and in this iframe, you have Facebook. If you don't look at the browser URL, you'll see Facebook. You can enter credentials and steal everything that goes through the iframe. So this header helps you protect users of being stolen their credentials or of that sensitive data. You have 3 values for this header. It's deny, same origin, the same URL of the website, and the specific URL is listed. It's covered by most of the browsers, except Opera Mini, I think, and it's cool. So with these 3 lines in your Nginx configuration, you can close 3 doors, which will prevent a human error in your code to be exploited by hackers. And 3 lines that should not change anything of your website, because these options should be like that in some case, because I was expecting it was working like that. But OK, so we're happy. We can jump. OK, not jumping. Strict transport security now. We'll spend a bit some more time. You may know this header. It's not trending, popular, but it's quite useful, and some of us are using. It's a header that prevents protocol downgrade, that prevents forged certificate when, for instance, you want to be google.com with a forged certificate. It won't work. So this header specifies to a browser, a user agent, that the next connection until an expiration will be only on the HTTPS transport. It means that if the user asks in its browser, give me http google.com, the browser will ask for https google.com. Connections are not made anymore on the 80 port, the port 80. So you have to be aware that it's after the first connection. Before that, you are vulnerable. But Chromium guys, the guys that works on the Chrome, the base of the Chrome browser, they imagine an application, hstspreload.appspot.com. On this application, you can register your website. If you register your website, this application will have a look at the headers provided by your web application. And if there's the preload option at the end of the header, then it will add it to a database. This database is distributed among the browser vendors, like Firefox, Edge, Microsoft Edge, Chrome, Safari. And every time they release new versions, they distribute the new version of the database. And the first connection to your website is secure. This is supported by all browsers, except Internet Explorer 8. It's not a drama, and it's really easy to implement. Have a look at this Nginx configuration. On the first configuration, I just redirect traffic from port 80 to 443. And on the port 443, I just add the header with a long expiration. I think it's 1 year. You can, as I mentioned in the previous slides, you can include subdomains. It means that any subdomains of the current domain will apply the rule of strict transport security. And we're happy. We can still jump and dance and everything. OK, let me. Up. Thank you. Content security policy. So we'll spend some more time on content security policy. It's quite a topic. Remember, 2003, 2004, it was the era of the Web 2.0. That's why they called it, how they called it. And during that time, some radical change happened to the internet. One of these changes is that before that time, content of the website were provided by the website owners. And at that time, that paradigm changed. Users became contributors to the website. Remember, it was the beginning of eBay. It was the beginning of MySpace, YouTube. And the content on this website was produced by the users, so potential hackers. This means lots of XSS vulnerabilities. And that's why content security policy have been made. They were a topic at Mozilla Foundation in 2003. And it was long, but it arrived in 2009. So a long time of thinking to propose this header. This header prevents XSS, but it's more than that. It provides directives, and for each directive you will list a white list of sources available for this directive. These directives are quite a lot. There are directives for scripts, still, images, videos. In the latest version, there's even plugin type, base URI. I don't even web workers. So it's very complete. As I mentioned before, for each source, for each directive, there's a list of sources. These sources are domain names. And there are 3 special sources: self, unsafe inline, unsafe eval. Self can be used for any directive, and it means the current domain. Unsafe inline is a special source for scripts and styles. It means that I allow to use inline scripting or inline stealing. And unsafe eval applies to JavaScript, to script source, and allows the use of eval, new function, set timeout, set interval. So this is an example of valid content security policy header. I use a CDN for my script and style. I allow to load from the current domain. And for any other directives, for instance, image source, it will fall back on the default source, which is the current domain. In this slide, is just a warning about the use of eval. Even if you are not using eval in JavaScript, be aware that jQuery, for instance, and other JavaScript libraries may use eval. For instance, jQuery uses eval when you fetch a DOM fragment from asynchronously in an AJAX request, and you append this fragment to the DOM. if it contains a script tag, jQuery will find it and eval the content. In vanilla JavaScript, if you do it by yourself, it's not executed. Okay, so a slide about unsafe inline. What's inline? It's this, and it's also image tag onload, it's inline. Image style equal, it's inline. Okay, so we are using inline everywhere. I'm sure you have inline script, inline styles in your application. So if you would like to use content security policies, you will be tempted to use the unsafe inline in your content security policy header. But obviously, it does not do the job anymore. Content security policies are here to prevent XSS, and using unsafe inline, it breaks everything. So, after a few years, in 2014, came the content security policies level 2. It brings new directives like the web workers and so on, and cryptography tools to help to allow inlining styles and scripts, and allow some of them, allow the parts you want to be executed, the rest won't be. Okay, so this is a new directive. It's not very important, so you'll read it later. So this is the cryptographic part. There's two ways to do cryptography with CSP. There's the nonce way, this one, and the hashes way. Nonce. A nonce is a random number generated on a web request. You generate your number, and for which style or script you want, a script tag you want to execute, you add this attribute, the nonce attribute, and in the content security policy header, you add this special source, nonce dash the nonce number. Hash works the same way, as you provide a checksum of the script that can be executed in the header, and at the runtime, you have to, at the runtime or before the runtime, you have to compute the checksum between the end of the opening tag and the start of the ending tag. This is hashes, for instance, and for styles. Now, let's have a look. I explain you why CSP level 1 were difficult to use because of the inline. I explain you that CSP level 2 fixes some issues. And we see here the caniuse.com tables for both versions. At the top, we see that CSP level 1 is widely implemented by browsers. So you can use CSP level 1 with confidence on all your users, because if a browser does not implement CSP level 1, it's not a problem. It's just a random header that is ignored. But if the browser implemented CSP level 1 and not the second level, then it doesn't work. And as we can see in the table below, only Chrome, Firefox, and the latest Safari version that was issued 1 month or 2 months ago, only them implemented CSP level 2. What can we do? Guys behind the CSP level of the CSP are smart guys. And you can use the cryptography in your header, even if it's a level 1 browser, because you will add an unsafe inline directive that is ignored by your CSP level 2 browser, but understood by the CSP level 1. So you will mitigate everything in most recent browser, and on older browser, you have a degraded version of content security policies. This slide says exactly the same, so if you did not understood me, it's here, but I hope you understood. So that's a good news. That's a very good news, because we can use CSP now to prevent XSS and close doors to attackers. Now we'll see how we could use CSP in your legacy project, your new project. It's not really easy because you have to know everything on your web application. Which scripts are executed, where they loaded from, which images, which videos, everything. And it's quite some job. Just before that, highlight on Nelmio Security Bundle. Nelmio Security Bundle provides content security policy support. And you can declare your directives for each directive, the sources. It provides twig helpers. So if you want to do cryptography, if you want to use inline script, inline style, you just have CSP script tag, CSP style, and magically it will compute everything. It's quite powerful. And it provides the report URI at the bottom. This report URI is not specific to Nelmio Security Bundle. It's in the CSP recommendation. It's been built by these smart guys. So this report URI will basically report any violation on your website to the URI you provide. And it's very useful because every time a violation occurs, a JavaScript is loaded from cdn.js.com, and you forgot it to add it to the whitelist of sources, you will be alerted and can fix it. And content security policies provide also this content security policy report only header that you can use alone and say, here are my directives, but it's report only. So the browser will compute, will check if everything matches. If there's a violation, it will report you that there's a problem, there's a violation, but you are not impacted. So migrating from no CSP header to a complete CSP, very locked website is possible with this mechanism that provides progressive migration. You can run with this header for a few weeks, months, and after fixing violation one after one, you'll have a completely working and secured, not secured, but more secured website. Of course, report URI is also available for the content security policy header. It works for both of them. And this is the kind of payload you will receive. It's defined by the recommendation, but some browsers, like Firefox, provide even more information about the violation. So you see that a script has been, the browser should have been loaded a script. It was not working. What was the directive at that time? Where the error occurred? It was not supposed to be here, but you know, I changed my slide just before the presentation because I moved to 16.9 to 4.3. So just a quick note about Angular, but it's also available to React.js. All these JavaScript libraries, modern JavaScript libraries, include support to content security policies. But it was not supposed to be here. Okay, is my website secured with content security policy? So, as I just said a few minutes ago, your website is not secured with content security policy. It's more secured. But security is not something binary. It's not secured or not secured. It's just a cursor you're moving, doors you close, and but it's never something perfect. So is my website secured? And even with all the others we've seen before and all the best practice we can have, No, your website cannot be secured. Moreover, your users are not secured because they can have web extension. Not web extension, but browser extension. This browser extension can read all the traffic on the browser. It reads all traffic in HTTP, HTTPS, they see everything. Cookies, all headers, all content, they see everything. So if you have a browser extension, it can see your password for your bank account, everything. Let's be very careful. We still have trackers. What happens if trackers are compromised? What if there's a breach at Intercom, Criteo, Google Analytics? What if they are compromised? It loads on the end-user browser and has access to everything that's happening in the browser. And as I said before, the CDN can be compromised. So we thought there was hope, but it's finally the end of the world. Okay. Do you remember the Great Canaan attack? The Great Canaan attack occurred, I think, 2 years ago, 1 year and a half. It's an attack that has been against GitHub, and if you're using GitHub at that time, you probably noticed it because it was not available for about a week. It was coming up and down and up and down. It was a bit disturbing because Composer was not working correctly. The issue in the Great Canaan attack is it was an attack from China. Any user outside China requesting for Baidu.com, Baidu.com is a Chinese Google. Every user requesting for a web page from Baidu, the request went through the Chinese internet service provider, and the response sent was modified, and some scripts were added in the response. So, as a user, when I wanted to search something, I had some JavaScript running in the background, eating GitHub in loop. And this was Chinese internet service provider hacking. So this could have been blocked by content security policy. This could have been blocked by strict transport security policy. And there's something much more difficult. It's the CDN compromission. And it's the real end of the world. Because there's nothing for the CDN compromission. Oh, yes, there is something. Okay, so late 2015, people were thinking about this problem, because there's a lot of scripts distributed by CDN, like cdngs.com or Google CDN that provide you jQuery in many versions. It's Subresource integrity. Subresource integrity is a very simple thing. It's like it's a checksum. You embed a script hosted at Google or any CDN, and you add an integrity property to the script tag. This integrity is a checksum value, the result. Your browser fetch the script, compute the checksum, compare it. If it's not working, it blocks. And it's quite recent because it has been released 1 year ago. It's quite well implemented in modern browsers, Firefox and Chrome. And it's already used by many users, like GitHub. GitHub uses Subresource integrity, but many others are already using. So the end of the world is saved by Subresource integrity. I don't have many time, but I would like to speak about root certificate authorities. it already happened in the past that a root certification authority is compromised. A worker has the key and is malicious, or keys are stolen. Many situations can occur. To avoid, because when I work at a root certification authority and I have the key, I can generate a valid certificate recognized by any browser for any domain. And that's a problem, that's a real issue. Because I can fake google.com with HTTP strict transport security. I can tell any browser that I'm the real Google, but I'm not the real Google. For that, the public key pinning has been developed. But it's quite controversial, because in every side, just parentheses, in every side there are resources at the top right. I hope you will enjoy them. So, as mentioned in the blog post in the top right, public key pinning works by providing public keys for certificates provided in the SSL handshake of HTTPS transmission. So you have to know the future certificate of your HTTPS configuration. So public key pinning is not, and I'm not covering this topic because it's not something becoming reality. It needs more work, but it's promising because we are smart guys working on this. And you can work on this too, because all these headers are issued by W3C under the group name WebAppSec, and they're on GitHub, and they're open to pull requests on the draft, new draft, and people will work with you to help you elaborate new recommendation implemented by browser after that. That's cool. Rabbits kissing in the grass. What a life. Okay. Most of all the links I used in my presentation are available in one of the last slides. It's very, very interesting to read. I encourage you to read them. It's about feedback, users implementing content security policies on their website, like Dropbox. It's GitHub engineering. It's a recommendation. I really recommend you. And I have 3 bonus for you. 3, not 1, not 2, 3. First one is securityheaders.io. It's a scanner from the internet. It gives a grade for your website depending on how you implemented security through headers. Second is reporturi.io. Reporturi.io is software as a service. It's free to collect violation report for your content security policies. It's not perfect because when you do that, you will have a lot of noise, and there's no plug and play tool at the moment. At Blackfire, we use that, but we had to build our own tool. And last but not least, Mozilla Observatory. It's very impressive. It's a very good tool, and it's open source. It's hosted on GitHub, and they have their own website. It's a scanner. You provide the address of your website, it scans it, and it scans through other tools like SSL labs, like securityheaders.io. I thank you to have been here. Thank you. And if you have any question, I'm here. I think I have 2 or 3 minutes for question. I'll be here. I'll be on Twitter. Don't hesitate to meet me. Thank you.